discarded, and all the members of a structure, as well as the applied loads, lie in a single plane. Many actual three-dimensional structures can be subdivided into plane structures for simplifying analysis. This is a three-dimensional model of a structure. When we consider the loads in the plane or vertical to this plane, the space structure could be simplified as a planar model as this figure shown. For such a truss bridge, under the action of vertical loads, a planar model can be used when we analyze it. Look at this great structure and a great roof. Can we simplify these structures as planar models? Obviously, no. Simplification of members. In analysis, if the dimension of a member's cross-section is less than a quarter of its length, we could use a center line to represent a member, ignoring its lateral dimension. External loads and three internal force components are acting on the center line of the member. Simplification of joints. The connection or joining of members is referred to as a joint. In general, the actual connections of members for a planar structure may be idealized into two kinds of joints. Hinged joints, as this figure shown. This is a computing model. Rigid joints. This figure shows the connection of a reinforced concrete column and beam. We could use such a computing model to represent it. This is a photo of wood roof. The members are inserted together at a joint. This is its computing model. When more than two members are connected, it is a multiple hinged joint. If a joint connects only two members, it is termed a single hinged joint or a simple hinged joint. Look at the roof of this structure. Members are connected by gusset plates. These gusset plates could be simplified as hinged joints. Look at this power transmission tower. Members are connected by hinged joints. Geometric characteristic of hinged joints. A hinged joint can prevent relative transmissions of member ends connected to it, but members may have different rotations. Its state of force is that a hinged joint is capable of transmitting forces but no moments. Rigid joints. This photo shows the connection of a reinforced concrete side column and beam. This photo shows the connection of a steel column and beam. They all could be simplified as rigid joints. All member ends connected to a rigid joint have the same translations and rotation. In other words, the original angles between the members intersecting at a rigid joint are maintained after the structure has deformed under the action of loads. Geometric character. A rigid joint could prevent relative translations and rotations. Its state of force is that a rigid joint is capable of transmitting forces as well as moments. Look at this figure. The connection of the steel beam and the reinforced concrete wall. The connection of the reinforced concrete beam and wall. The connection of these steel members. They all could be simplified as rigid joints. In practical engineering, We could find the third type, composite joints. Look at this figure. We could use such a computing model to represent it. Another example, the two wooden members are connected. This is the computing model. They are all composite joints. Look at this structure. This is a rigid joint. This is a hinged joint. And this is a composite joint. Simplification of supports. There are 4 conventional types of supports for a planar structure: hinged support, roller support, fixed support, and directional support. Hinged support. This figure shows a hinged support. Only the free rotation about the hinge can take place. The support reaction could be represented by a horizontal and a vertical component, both acting through the center of the hinge pin. This figure shows the connection of a reinforced concrete column and the foundation. There are notches here. It can be simplified as a hinged support. We usually use such computing models to represent a hinged support. Roller support. This is a roller support. The motion in a direction perpendicular to the support surface beneath the roller is restricted, so it supplies a reactive force Fn along the roller support, as this figure shown. This is its computing model. It could move in horizontal direction and rotate freely. These kind of supports are widely used. Look at this bridge. The connections between the main and subsidiary beams can be simplified as roller supports. We could see details from these figures. They are all roller supports. Fixed support. Both translations and rotation of member ends are prevented. So a fixed support supplies a reaction. The magnitude, point of application, and the direction of which are all unknown. We could use a horizontal force, a vertical force, and a couple to substitute it. This is a computing model, and its 3 reactions. Directional support. This figure shows a directional support. We could see that a directional support restricts all relative movement between structure and its foundation, but slides along supporting surface. This is a computing model. It supplies a force perpendicular to the supporting surface and a moment. For this directional support, it supplies a horizontal reaction and a moment. Difference and combination of 4 supports. A vertical roller support, classes. A horizontal roller support is equivalent to a hinged support. We could use such a computing model or this model to represent it. There are 2 reactions. A vertical roller support places 1 more vertical roller support is equivalent to a directional support. The resultant forces of 2 parallel forces are a force and a moment. A directional support places a horizontal roller support is equivalent to a fixed support. This is seldom used. We usually use this computing model. It supplies 3 reactions. That's all for today. Thank you for your attention.